This is going to be an example of week 2 lab number 3 involving a control problem with multiple inputs and outputs. First of all, I have all of the components laid out that we're going to use for the lab. Here's the 2 relays here, a red and a green LED, the start button switch, the stop button switch, 2 560 ohm resistors, and the phototransistor. For the phototransistor, has a glass dome on the top of it. When you shine light on it, it forward biases the base and emitter junction and allows the transistor switch to turn on. Looking at the bottom side of the transistor, we have a little tab right here which indicates that this pin right here is the emitter. The center pin right here is the base, and the outer pin here is the collector. So these are the only 2 pins that's going to be used in the lab is going to be the emitter and the collector. This one here can be left open. The schematic diagram that we're going to use for this particular lab is listed right here. So what we're going to attempt to do is to go through a step-by-step procedure of assembling this particular lab. First thing that we're going to do is we're going to focus on the first rung of this ladder network. So we're going to install the start switch, the normally closed stop switch, and our first relay. So we'll go ahead and start mounting the components onto the breadboard. We'll start off with our start switch here. Has 2 pins on it, and based upon the schematic diagram, one of the pins is going to go to positive 12 volts, and the other pin is going to be connected directly to our stop switch. So I'm going to go ahead and insert that into the board, and I'm going to put this diagonally, and I'm going to put it across one of the numbers here, and I'm going to choose number 60 right here. And just make sure they're both in row 60, and we'll press it down. Go ahead and put my board back together here again. Now we'll go ahead and install our stop switch, which I'm going to put it in relatively close proximity. Now with this particular switch here, you can use your ohm meter to determine if these 2 pins right here is the normally closed or either this one. So for the time being, if I'm not mistaken, I believe these 2 pins are the normally closed, but if not, you can always turn the device around. So I'm going to go ahead and place this on the board as well. And I'm just going to choose just an arbitrary position right here and just slip this in a set of 3 rows, and I'm going to choose row number 50 to put at least my center pin. Now I'm going to let this row here represent positive 12 volts, and I think I'm just going to try to use this board just all the way across here, and I'm going to let this channel over here represent my ground. So I'm going to connect a couple of wires, one for my positive 12, and then my ground will be right here. I like to use black wires for my ground. So I'm just going to stick this right here. and I'm going to stick a red wire in for my positive 12 right next to the red channel. Now, according to the schematic diagram, the left side of the switch is going to be connected to positive 12 volts. So I'm going to run a little jumper from this pin on the left over to the positive 12. So now we have taken care of this connection right here from the left side of the switch over to the positive 12. The next thing that I'm going to do is I'm going to connect the right side, the other pin, over to one of the pins of the normally closed switch. So I'm going to connect row 60, and I'm going to connect that to my center pin here. Now, based upon the schematic diagram, the other pin of the normally closed switch, I'm going to connect that to pin 1. On the relay, pin 1 and 16 represents the coil of the relay. So I'm going to connect the other pin of my normally closed switch over to pin 1 of one of my relays. So I'm going to insert the relay on this side. Make sure that it straddles the center channel. So I'm going to connect pin 1 of the relay over to this pin right here. The center pin I have in row 50. Now, based upon the schematic diagram, so now at this particular point I have one leg of the start switch to positive 12, the other leg connected to the center of the normally closed switch. The other side of the normally closed switch is going to pin 1 of my coil, my first relay. Pin 16 of my relay I will connect to the ground bus. So at this point we have a nice series connection with the start switch, the stop switch, the relay coil, all the way over to the ground bus. Now at this point we need to take the normally open contacts of this relay and connect it directly across our start switch. So those two are wired in parallel. So I'm getting ready to make those two connections. For this particular relay, that would be pin 4 and 8. So now I'm connecting pin 4 to one leg of the start switch. I'm going to go ahead and put these switches tend to pop out rather easily. You can cut some of these little tabs off here to make it stay in the channel a little bit easier. And now I'm going to connect pin 8 over to this side here in row 60. You know, the wire lengths are a little long, but we just want to make sure that we have the proper and appropriate electrical connections here. Now, looking back at the schematic diagram, we have successfully connected the start switch, the stop switch, the relay coil of the first relay, and then the normally open contacts, which is pin 4 and 8, and we've connected those directly in parallel with the start switch. So we're done with this first rung of our ladder diagram. Now the next thing that we want to do is we want to build the second rung here. That will involve using the relay contact, and this time we will probably use the normally open contact on the opposite side here, which should be pin 9 and 13. So we're going to connect those two up, 9 and 13. So we'll go ahead and connect up pin 9. Now, based upon the schematic diagram, one of the legs, it really doesn't matter. We can connect 9 to positive 12 and then 13 over to another relay, but you can interchange. It really doesn't matter. But I'm going to make a choice to connect pin 9 of the relay contact to positive 12 for this relay right here. Now, based upon the schematic diagram, this is the relay contact of the second relay. This is the normally closed contact. So I'm going to go ahead and install the second relay on the board, and I'm going to put it down somewhere below this one to represent the second rung of our ladder diagram. So I'm going to stick pin 1 in row 35. So our normally closed contact here will be pin 4 and pin 6. So I'm going to go ahead and connect by my own choice, I'm going to connect pin 4 over to pin 13 of this relay. Since we need to make a series connection. So at this point we have accomplished making a connection of the secondary normally open contact, and we place that in series with the other relay normally closed contact. So we've accomplished a path from positive 12 volts over to this contact here on the schematic diagram. Now, since we have pins 4 here, we need to connect up pin 6, and pin 6, which would represent the opposite side of that, would need to be connected to our motor. And the motor that we have in our kit here, all I did was just took a couple of wires, bent it, and then just crimped them together right here to have a solid connection. So by my own choice, one leg, which I'm going to choose the black wire, I'm going to connect that to ground. I'm going to do that right now. I have to straighten the pin out here just a little bit. Stick that in the ground bus. Then the other wire, I'm going to go ahead and connect that to my second relay contact, which is going to be pin 6. I'll go ahead and kind of move some of these wires out of the way. So, in our assembly, we have accomplished connecting our first relay contact, normally open, to our normally closed second relay. We've connected the second relay contact that's normally closed to one leg of the motor, and the other leg of the motor we've got tied to ground. So now we have accomplished this series path here. Now, based upon the schematic diagram here, we have a green LED and a 560 ohm resistor that's directly in parallel with the motor. So I'm going to go ahead and build a series network involving the green LED and the 560 ohm resistor, and then put that directly in parallel with the motor. I'll call you. Bye-bye. Here's our green LED. Got to make sure that you put it in right. This flat edge right here indicates the cathode, which would go to the more negative point. So you've got to make sure that you don't put that in backwards. So I'm going to, over on this channel here, letting this zone represent my second rung of my ladder network, I'm just going to choose just an arbitrary position and mount that. Then I'm going to put my 560 ohm resistor in series with that. And now I'm going to make a connection between the anode and connect it to this leg of the motor, and then take this point right here of the resistor, and then that's basically going to go directly to ground, which will in essence put this series network directly in parallel with our motor here.